Okay, this is Dr. Williamson. I'm going to go over determining the enthalpy of reaction for the reaction of solid magnesium with hydrochloric acid to produce magnesium ion and hydrogen gas via constant pressure calorimetry. And these are pretend made up numbers. So I just I don't know if these numbers are actually going to be correct. Just making these up. So these are sample illustration numbers. Okay, guys. I don't know if these are going to be the correct numbers. It's the temperature difference that I'm inventing might be what's wrong here. But you'll get the idea. You'll get the mechanics of how to do the math. So let's say I take 50 grams of water and 0.12 grams of magnesium. I should have more sig figs than that. And I put that 0.12 grams of magnesium, 50 grams, not of water, but of, let me correct this, 50 grams, not of water, but of HCl solution. Okay, that was my first mistake. Okay, and so this should be a HCl solution, but we're going to approximate it as water because it's going to be mostly water. We're going to approximate it as water. Anyway, I took my 50 grams of hydrochloric acid solution. It was initially at 20 degrees Celsius. I threw in my 0.12 grams of magnesium. I let it react. It went from 20 degrees Celsius to 30 degrees Celsius. The heat that the hydrochloric acid solution absorbed is equal to the heat that the reaction gave off. So I want to calculate how much heat the hydrochloric acid solution absorbed. Well, that's going to be equal to, let's do this, text. Let me change this to blue just to be consistent. We had 50 grams times, what's the heat capacity of my, 1 molar or 10th molar hydrochloric acid solution in the lab? 1 molar hydrochloric acid solution. We don't know the specific heat capacity of 1 molar hydrochloric acid solution, but 1 molar hydrochloric acid is overwhelmingly water. So we're going to assume the specific heat capacity of hydrochloric acid can be approximated to be very similar to the specific heat capacity of water, gram per Celsius. Okay, so it's a decent approximation. And here, I made up these numbers here, 30 degrees Celsius, 20 degrees Celsius. That's where the numbers are probably wrong that I just made up. Let's just go ahead and go with that. And that's what we're going to learn to do the mechanics of the lab. So we're going to go 50 times 4.184 times 30 minus 20 is 10. And that's going to give me basically 2090 joules is how much heat energy that the water absorbed. And that means that also Q reaction is going to be equal to negative 2090 joules. It's the same number of joules, just opposite in sign. Okay. And then something I need to do is look up the molar mass of magnesium. Now I want to calculate the enthalpy of the reaction. I wrote delta H, I wrote DH instead of delta H. The enthalpy of the reaction will be equal to Q of the reaction divided by the moles of the magnesium I used in this reaction. The moles of magnesium will be the 0.12 grams. I should have waited to more sig figs, but I didn't because I'm making up problems. Divided by the molar mass, which is 24.305. This is grams. This is grams per mole, right? So I'm going to go 0.12 divided by 24.305. That's going to give me, I'll just go ahead and type it, 0.0049 moles of magnesium. So my enthalpy, delta H of reaction, remember enthalpy is the heat of the reaction under constant pressure conditions, right? That will be negative 2090 joules divided by 0.0049 moles. And so let me go ahead, 2090 divided by 0.0049. And I get a big number, so let me divide that by 1,000. And I'm going to get equals negative 427, negative 427 kilojoules per mole. Okay, and so a point I want to make is, I want to emphasize this, okay, that is a sample number for illustration purposes only, because I just invented the temperature results to create a problem to help you guys with the math mechanics. Okay, you guys get that? So I invented the 20 degrees Celsius and the 30 degrees Celsius range, so I could create a problem so you guys know how to solve this. So I'm not saying you should get 427 kilojoules per mole. I don't know if that's correct or not, but you know, I invented it so you guys know how to do this lab and kind of how to solve the problems. Okay, guys, so you know, don't hold me to that. I just created it up on the fly. Anyway, I hope that helps you guys with the first part of the lab, and hopefully I can, you know, I'll do the second part of the lab later. Okay, then I'll try and do some more problems for you later.